Hi, my name is Pierre Ricau, and people call me PY, and I work at Square. I'm an engineer at Square. And today we're going to talk about, let me try this, ARAWR, fantastic bits, and where to dex them. So I work on a team that makes APIs at Square, but I can't get into too many details. However, so you probably noticed that there's like a Snapchat ghost here, and the reason for that is because I gave this talk at Snapchat first. So you'll see a few ghosts every now and then. Just thought they were cute, so I kept them. So a few years ago, I made a library called Leak Canary. Who's heard of Leak Canary before? A few people in the room, cool. So we're not going to talk about that at all today. But I have some stickers for your laptops if you want. So at the end of the talk, I'm happy to give some away. Anyways, so what's the talk about? So clearly, ARAWR is like the sound of a dinosaur, right? And what we're actually talking about is extracting delicious spaghetti code out of a dinosaur, but by first putting the dinosaur into a fat shoebox and then putting the shoebox to a diet, which might not be very clear. So I'm going to try to help you understand by using pictures. So it's extracting delicious spaghetti out of a dinosaur into a fat shoebox and then putting the shoebox to a diet, right? Right now we should be pretty clear on what's going on in this talk. All right, so let's go back to the title a little bit, maybe look at it in a different way. So what is this ARAWR thing about? It's kind of two parts, AARAWR, which is an Android library, like a jar with resources. And then RAWR, which is the sound of a dinosaur. But also an acronym for sometimes you get to the right answer by following the wrong route. So we're going to talk about how we can build the right thing, and sometimes to build the right thing, we have to try different things, and they may be the wrong path, but they eventually lead to the right answer. And in doing that, we learn a lot in the process, and I'm going to share what we learned with you. So I'm ready to start the talk, like the actual talk. I only have one issue. I can't talk about the project that I've been working on because it's not released yet. So we're going to do something else. We're going to pretend that I work at Snapchat. And so you know Snapchat, it's a great app. It's got many features, and one of them is stories. So the problem with stories, and they're great stories, but the problem is Snapchat is a very specific social network, and you kind of want stories in other social networks. Like what if you could reuse them, maybe in Facebook, maybe in Instagram, right? Stories everywhere. So what we actually need is a stories SDK. So let's take a step back and think about it. What if we wanted to build an SDK that enables other apps to have that feature that we have in our main app? So how do we do that? The first thing you can come up with is we're going to rewrite that code from scratch, right? That's like probably a sane option. The issue is, though, that feature that you're trying to make available as an SDK for other apps is so big. For example, in our case, it would be 100 screens. And this is like we started logging the navigations from one screen to another, and this is the graph that we got. We still couldn't understand what was actually going on. So rewrite could be done, but it would take a lot of time, like a year or two. And in the meantime, you're still trying to add new features into the thing. So option number two, you could fork that code base and start from there, right? So you just take what you have, fork it, clean it up, and now you have an SDK. The problem is that then it's a similar issue where you have twice the QA. It's a lot of work, and you have two divergent code bases. So the maintenance is heavy. So obviously, the next thing that comes to mind is extracting the code out from the current code base. And that's a great idea. And then the app in the SDK would use the same core. The problem is the code base is a dinosaur. And it's very old and dangerous. There's a lot of pitfalls, and nobody really understands what's going on in there. It's a lot of spaghetti code. It's all tangled together. That would take a lot of time to extract it out, probably a year or two. So on a slightly related note, I recently saw a talk called Cloning Yourself is Not an Option by Camille Fournier. It's really great. It talks about how you can't do everything. But one of the interesting quotes one of the interesting things she said is, great engineers are really good at identifying the right problem to work on. Sometimes the important thing is getting the code out the door, proving that somebody wants the code, right? Are we going to spend 2 years trying to extract this code, and then at the end we realize no one wants it? No one actually wants stories anymore. So how can we do that? Creating that SDK in less time. The extraction process, the refactoring that goes with it takes a lot of time because of how the code is tangled. Well, we got an idea, kind of a crazy idea, if you ask me. Instead of first extracting the SDK, and then having an SDK, what about we make an SDK first and then we extract it? Let me explain. We're going to take the dinosaur with all of its app code, all of its spaghetti code. We're going to put it into a shoebox, and that shoebox will be an API, like a shim layer. And then that's our SDK, the entire code base. And over time, we'll move code out and we'll shrink it, and that'll be an actual real SDK, a clean one like you wanted. So in other words, so you might have seen the usual MVP graphic. So MVP, if you're not familiar with it, it's the idea of a minimal viable product, and the idea that you try to do the least amount of work to get product feedback. And so there's someone, actually Henrik Nyberg, made this really nice graph that shows how you shouldn't build a wheel and then, and only at the end you have the car. You should build something that's usable, but that doesn't have all of the features. So it goes from like the small thing to the big thing. What we're actually doing here is the reverse. We're shipping the car when customers actually want the skateboard. But we'll get there over time. All right. This talk also has some code and technical stuff, by the way, but I like to start with pictures. So it's a crazy idea, and we needed to convince our teammates and leads, and the way we did that was by prototyping, and we were done in about 2 days. So we have a thing called Hack Week at Square, where we spend a week doing other things. So we used 2 days to do that, and then, nothing. It was a cool break out of the week, so that was pretty great. We did a pilot in 1 quarter, and I'm going to talk about that and what comes next. So let's focus a little bit more on the technical details. So we have an app project that actually contains a lot of modules and also external dependencies. And we want to bundle all that into one library. That's not something that is super common. It happens every now and then. There's this concept of a fat jar you might have heard before, or Uber jar. So we want one AARAWR, which contains the code and the resources. But more than that, actually, ideally, because we're shipping all of that code that we don't really want to expose to the customer because it's not really made for the SDK, it happens to be there. We don't want all of these classes to show up in their class path in the IDE, right? They should be looking at just the API surface, not at all of the crazy implementation details. So that's another interesting problem. We want to hide the internal classes. And finally, we want to limit the impact on developers. One of the things we thought initially was, oh my God, we have so many classes, they're going to need to enable Multidex, and it's going to make their build slow. So let's take a look at what is inside an AARAWR, this Android library, and see if we can figure out how to build it, how to build the one we need. Surely this must be well documented, right? Well, it turns out that this is the entirety of the documentation of what's inside an AARAWR. There's an issue file on Google, so they'll eventually add more. But right now, that's what it is, and it actually misses some entries as well. So the first we notice is this Android manifest, which really describes the components that are exposed by the library to the system, as well as permissions. So that's sort of reasonably easy to understand and build. Then there's classes.jar, and you're probably all familiar with jars. So what does this jar contain? It contains bytecode. Now, if you know a bit about Android, you know that bytecode is not the full story, right? This is like the pipeline of how things get installed to when you install an Android app. So you start with Java, and a Java file actually produces many class files, right? Because you have anonymous classes that turn into their own class file. So you get bytecode. The bytecode is turned into Dex code, and it's just one file, one Dex file. It contains all of the classes in one place. which was actually a very optimized format so that you don't have to move around in the file system when you're trying to load classes. And so the Dex file is then packaged into an APK, right? So when you make an AARAWR, you're shipping, bytecode class. You're shipping bytecode, and then that gets integrated with all of the other libraries and the application code, and it turns into a Dex file that then is shipped into the APK. And then that gets installed. And so in the world of today, there's kind of two paths, the pre-art world and the post-art world. Either the Dex file is just dumped on the file system, it's optimized, but pretty much almost identical, or it is compiled to OAT, O-A-T, which is really just native code. That's what ART is about. So at install time, it gets compiled to native code. The name OAT comes from a pun where it basically means of ahead time, which is a revert of ahead of time compilation, because it's ahead of itself. So it's like of ahead time. It's a really funny joke. So if you're interested in learning more about Dex, actually Jesse Wilson made a great talk on Dex Ed, and he actually spends the entirety of the talk going over these bytes and explaining what each of the byte is about, which is a bit crazy, but I assure you it's really fun. So let's go back to our classes.jar. Is that all of the code that you have in an AAR? Turns out, no. There's also a /lib/name.jar, which I do not know what it's for. It adds more classes, and they have the same responsibility as classes.jar. It's been used by the support library to add implementations, but you can also navigate to them, so it's not very clear why there's a separation here. But anyway, so that's what it looks like in the support library, for example. You have internal impl, but you can totally see those classes. They're not like hidden like an API and an implementation. So we have this. Let's move on. We have resources where you have all your pictures, all the Android resources. You have this, r.txt. Who's seen r.txt before? Yeah, it's okay. Cool, a few of you. It's a bit of a confusing file. When you look at it, that's what is in there, like a sort of a type, int, and then some sort of like style of resources, type of resources, and then a name, and then some random hex value. So this is about Android resources. You might know that. So when you have a resource in your Android app, it turns into I guess your build tool generates for you an int, a constant. So R is a class over there, and drawable is an inner class of R, and about is a field that holds a value. And that lets you reference resources, or it's an identifier to resources. So you have this file that's generated. Now, that's great, but the way this works is that this is global to the application. There's no notion of namespace, which means that if a library wants to generate its own R file, it cannot say, I want to claim number 42, because another library could say, well, I want to claim number 42, and then you'd have conflicts. So when Android introduced libraries and AARs, they had this really cool idea. It's kind of a hack, but it made things work, where they realized, okay, you need to look at the screen. It's going to be a very tiny change. They removed the final keyword. Let's do it again just to see, because it's a cool animation. Final keyword goes away. So what does that mean? So basically what they did is that because in your library, the field is not final anymore, the value doesn't get inlined. So you can still reference it in your code. But then that R class is actually not shipped in the AAR. They remove it entirely. And instead, they ship this r.txt file, which just lists the resources. And then the application is in charge of regenerating those R classes for each of the libraries. So you can see that this is what was in the library, and this is what ends up in the application, which is the exact same class, but with a different value. And the field is final again, which means it gets inlined. Cool. So that's interesting. Let's continue and look at assets. Same thing. They're just copied over. I mean, you just want to take your assets, and they get copied over in the application. There's something going on with the sound here. Native libraries. So native libraries similarly are in this folder, and then they get copied over in the APK. And similarly, ProGuard is a way to tell ProGuard how to handle your library. you shouldn't really put anything in there because the application owner should be the master of this. And lint is a way to bundle lint rules. Okay, so we know what's inside. How do we make an AAR? So we had these constraints, and that's what makes it very, very interesting, because it's not something that's very common. We need one AAR. We don't want to show the internal classes, and we want to limit the developer impact. And that's when we got an idea, I guess another idea, another crazy idea. And I have to thank a few friends for that, Ty Smith and Gautam Kolam, who gave me this idea of dynamic Dex loading, which we're going to talk about in a minute. So let's say that we have all of our spaghetti code, right? Instead of putting that into classes.jar, we're going to directly compile all of that bytecode into Dex. And then we're going to put that in the rest folder as a raw resource. And then our classes.jar is going to contain just bootstrap code that's just going to load that dynamic code at runtime. So it turns out that Android has something called Dex class loader, where you just give it a Dex file, and it's going to load all of these classes. And that's great. The only problem is it only supports 65,000 methods. So we're a bit limited here, unless you can split the code into independent modules. But remember, it's a spaghetti code. We can't do anything. So can we do something about this? Let's see. So instead of this, what we really have is this, right? We have many, many dexes because we have too much code to fit into one Dex file. So what we're going to need to do is to load all of this in a unified way. And Android is not supposed to support that, except it does. You might have heard of something called Multidex, which is a library that lets you load many dexes into your app. And so the way it works, we should look at that, because if we can understand how Multidex works, then we can redo the same thing on our own. And it's interesting to learn, right? So Multidex, the way you use it normally is you just add the library, you turn on Multidex, and then you say multidex.install this. So let's see. What happens in install? So Multidex for me was this crazy thing I really didn't want to know. It sounded like it was really dirty, a lot of code. And it turns out that it's actually very little code. It gets the current class loader. OK, that's easy, right? And that class loader happens to be of a certain type that they know about at runtime, but is not exposed as an API. Then it finds the directory where the dexes are supposed to be copied to, because they are in the APK at first, and you want to move them to a folder. And then it copies those dexes into the file system. So that's an easy, you just unzip the thing, copy to that place, and then load the classes, install the dexes. So that's where the magic happens. And what is the magic about exactly? So when you look at the implementation, it just says, oh, if I'm this version, do that. If I'm that version, do this. OK, so not very interesting. Let's look at one of the implementations, so v14 here. At the core of this, what it's doing is it takes the class loader and finds a field called passlist by reflection. And then it obtains the value in that field. And then it's basically an array, and it puts one more value or n more values into that array. So this is an array of files. And essentially, a Dex class loader has the ability to load n number of dexes, but it won't expose that as an API. It only the API only lets you load one at a time. So, but with this hack, you can basically add more, right? And so if Multidex is doing it, that means we can do it. And therefore, we solved our problem. We have this crazy idea that we can turn into a reality. Android always supported Multidex from the beginning, but they just never exposed the API. All right. So we learned how Multidex work. Now, how do we build that AAR, that crazy AAR? What we want to do is grab all of the transitive dependencies and put all of them in one box and then Dex them, right? So all of that stuff sounds like work. Except then we got another idea, which is when you're building an APK, it's actually doing all of that for you, because the final application has all of its transitive dependencies embedded into it, and it has Dex code. So we can just reuse that, which means we're just, instead of creating an AAR plugin and an Android library plugin, we're actually going to work on top of the application plugin. and we're going to let it build the APK. And then we're going to fish into the build directory. So we have like a task that's a zip task. And that task will look from one folder and grab r.txt from the build folder, grab other things from the build folder. So it's basically let it build an APK and then fish into the build folder to make your own AAR. So similarly, we can do resources and assets, and the classes.jar, that was our API bootstrap. And then the Dex files, we're going to find them in the build folder and put them in rest row. And public.txt actually wasn't mentioned it's not mentioned in the description of AARs, but it is the place where you describe resources that can be overridden. When you have public.txt in an AAR, then any other resource cannot be overridden by the app developer. Only the public.txt resources can be. And finally, this puts the AAR in the right place. All right, so that's cool. So we were able to ship a pilot with this in 1 quarter, and we were very excited. And the next step felt like we had this giant SDK with so much code, and now we needed to shrink it, right? And you'd think, well, what could we do to do that? So we could run ProGuard, and ProGuard would eliminate the classes that we don't need, right? The problem is that it's a bit of an easy solution, but that still means that we're maintaining this huge code base where we don't know what's going on exactly. So it would be much better to actually clean things up and modularize. So we want to clean up the spaghetti code. The problem is we still can't extract that SDK because it's still so big. So instead, we decided we would do what we call thinning, which is we're going to take things out one at a time and keep shrinking it. And it's great for modularizing the code base because all of a sudden, everybody's excited because we're making things better. We're actually creating modules. So it's not just the SDK, the app as well is improving based on thanks to that. So I found also a nice trick to get other engineers to help, which is to make reps. It turns out that if you offer people things like, I'm going to make reps for you, then they get excited and they work for free. So it's pretty cool. Another thing we did to help out was track the size of the SDK. So today in our CI, so we build with Gradle, but our CI invokes a bash script that then invokes Gradle. And so if I wanted to grab some of these statistics and like class counts and method counts, I had to write some bash, which I've never written bash like in my life before, or more than one line at a time, right? So I'm like, how does that work? It turns out that you can write functions in bash. However, functions parameters are kind of more interesting, where you don't name that, they just have an order. So you know that number 1 is the first parameter, number 2 is the second parameter. So the first thing you do is kind of extract variables based on that. And then so what we were interested in is finding the number of classes and methods in our SDK and the size. And so it turns out that every Dex file has a header, and that header actually has a count of methods and classes in that Dex. So, and that value, the method, the size, the number of methods, and the number of classes is actually somewhere in their header. So the values, the 88 and 96 numbers that you see here, is just the number of bytes at which the value start. And uint_less is the size of one int. So capturing an artifact size is easy. You just invoke some Ruby. Don't ask me why I'm invoking Ruby from Bash. You should ask Jake, because I copy-pasted that from his scripts. He's over there. You can ask him the question later. I actually don't know. I didn't really care. I was like, this works. Moving on. So then we want to list the Dex files, which is reasonably easy. All we have to do is, so unzip, you can pass -L. It's not going to actually unzip on the disk, but it's going to list all of the files. And then we grep for the Dex files that we want. And then we compute the class counts. So to do that, you have a Dex file, and you call unzip, and you ask with -P, you actually ask for, give me the bytes. Don't give me like an actual file. Don't unzip for real. Just give me the bytes of that file. And then we took the first n bytes until the position of the class count plus the size of one int, and then you have that big kind of beginning. With tail you remove the beginning and you actually get just a value, and you turn that into ints. This is not very important, but it's kind of interesting to know that you can just do all that stuff and you get what you want. You could do the same with method counts, and eventually just output the value or put it somewhere like on the pull request, that kind of stuff. Okay, so that's cool. That was just a way, I just thought this was like a cool bit, like you can actually go into a Dex and kind of get these values. So we had a pilot out, everything was fine. Well, actually, no, nothing was fine. Everything was on fire. We had several issues. One of them is that we had turned all of these dependencies into one big box. We hadn't really thought for long about transitive dependencies and how we depended on public libraries, which means that we would actually embed public libraries into our SDK. But those public libraries would also be used by our users, the developers. So that led to class loading issues, actually pre-Android L. So here's something interesting. Starting with Android L at runtime, it doesn't care. If a class has already been loaded and it's available in another Dex, Android is like, yeah, fine, I don't care. I'm going to ignore that one. I already know that class. But prior to Android L, it would crash. So we had a lot of class loading issues. So we were like, OK, I guess we'll just do on L and up. But then the other thing we hadn't realized was that on L and M, we had a slow startup. And here's why. When you install an application, when you have all of these Dex files, normally starting with Android L, they're compiled into ART code, right, into OAT files with Dex2OAT. And that happens on install. But here we're sidestepping. We're saying, no, actually we just have a few classes, and we're going to load these Dex files from this resource folder. And so the actual compilation step happens at the time we actually load them. So this would still happen, but it would happen at runtime instead of install time, and basically on the first install. And so that took up to 50 seconds on recent tablets, which was a problem. So that was a problem. And then another issue was that the Gradle updates were hard because we were dependent on the Gradle internals. So we learned a lot. We tried our thing, and we had our constraint, and now we need to add new constraints, like we don't want any class loading issues. We should know the errors are at compile time, and we don't want a slow startup. So if we come back to this drawing, there's another hack you could do to get rid of the slow startup, which is this all happens because when you're trying to load these Dex files, they are compiled to ART. So one thing you could do is to disable the compilation to ART. And there's actually a library, TurboDex, that does that. That is generally a really bad idea because it means that you have runtime code that's really, really slow, right? It's also, so it's a Chinese library, which means it's been translated a bit fast. I love saying that the TurboDex was born to solve this problem, like to open the God mode for Android VM. After using TurboDex, no matter how much Dex file you need to load, it will be finished in a very short time. And initially, it sounded like a magic recipe, but it turned out that it's going into native code to basically prevent Dex2OAT from kicking in. So bad idea. Let's stop doing this bad idea, and let's try to do things differently. So we looked at the constraints, and we said, okay, all right, so we still want to hide internal classes, right? So this is the thing where we're like, all of these internal classes, we don't want them to show up. But it turns out that Android already supports that. There's something called the APK scope. So you can add a compile dependency, or you can add an APK dependency. And an APK dependency can only be a jar. It cannot be an AARAWR. But what that means is that all of these classes that are in this jar are going to be included in the APK, but they will not be available in the class path of the IDE, in the class path of the developer. So you cannot reference the classes directly. That is exactly what we wanted. We just needed to know that this existed, and we didn't. So that's great. We can hide internal classes using the APK scope. And essentially what we're doing is we're going from this to this. Now we have an impl.jar in APK scope, and all of the spaghetti code goes in here, and then we have our normal AAR. And what's nice about that is that it takes care of 3 of our constraints. Hiding internal classes. We don't have class loading issues anymore because we don't have like magic extra class loading at runtime. And we don't have the slow startup. So that's pretty great. However, instead of one AAR, we have an AAR in a jar. It's still pretty cool. All right, but what about the dev impacts? Does that increase the build time? Because really, we're forcing our developer to use Multidex at this point. Well, yes, but also there's this thing called predexing, right? And we just should have thought of that, where every library is compiled once into a predex Dex, and then in development, you're using Multidex, and every library is just a different Dex. And that makes your development cycle much faster. So slow builds, not a problem. Predex is fast. We still have the issue of duplicate classes, right? We're still embedding all of our dependencies, including public libraries. But now, at least, the errors are going to show up at compile time because all the classes are visible. So how do we get rid of that issue? Well, we just need to exclude those dependencies from our AAR. So this is interesting. I hadn't seen that operator before. It's called the spread dot operator. So all is all of the configuration. It's actually a list. And start dot means you need to call the method called exclude on every single value of this collection, which is all. So it basically says for every configuration, you should exclude the group, the dependency group, Android, Android support. So we still have a bit of an issue here. So essentially, our AAR is shrinking and now doesn't have the public external dependencies. However, you have the typical transitive dependency issue where if you're using version A of the library and someone else is using version B of the library, then you have a conflict, and they're going to and sometimes you have incompatible libraries because of that. So it's a balance, but one way to work around this is something called shading. And there's a library called jar which does that. And what it does is that it recompiles the bytecode and changes the packages or whatever you want, really, so that you don't have conflicts. So it's really a choice of like a big library like the support library. You wouldn't want to do that because you're duplicating it. But a small library like Timber, you might want to do that because it's just login and it's just one class, and so you can use your own and they can use their own, and there's no problem. So finally, you remember that giant zip task. So which had a dependency on the Android plugin internals. It's pretty bad. So instead of this, we realized it was important to stop relying on the internals and just start building the resources ourselves and basically detaching ourselves from the Android Gradle plugin, which lets us update it without having to change everything every time we try to do an update. So as we worked on this, we kept saying, oh, we have this AAR module and it's an AAR, so we're like AAR, and it was annoying. So we decided to call it a RAWR because that was much more nicely, the sound is much better, and so that's why. That's actually why this talk said RAWR, and then we tried to figure out an acronym for it. That's all I got. So to summarize, I think we learned a few. We learned a few things here. We went over different crazy things. Obviously, I'm not saying you should do this because a lot of it is bad or very dangerous. What's interesting is understanding, prioritizing for value. Like if you want to ship soon, you should definitely start digging and figure out solutions to your problems. But then when you shipped and you're learning and you're moving forward, you should take a step back and decide, was this the right decision to make? You shouldn't stick to your decisions. But you should never be afraid to dive into something that looks scary because you learn a lot in the process. And that's it. I'm done. Actually, one more thing, or two more things, maybe three. I work on the API team, so we make payment APIs. So if you're ever looking for payments on integrating with payments on your websites or mobile apps, you could check out this URL. If you have feedback on this talk, on our APIs, you can email me. The other thing you can do, so this is a Gradle conference, which means I assume a lot of you deal with builds. Turns out we're hiring for build engineers. So, and I promise you, you're not going to get to do all that crazy stuff we just talked about. That's done. That's the past now. But anyway, if you're looking for something for the next step, Square is looking for build engineers. We also have some engineering content on the corner, and this is my Twitter account. And I might have a few minutes for questions. It's going to depend on when someone takes me out, I guess. Anyone has any question? I'm on the count of 3. And then, of course, I still have the stickers. I'll give them away if you want. You don't have to, by the way. It's not mandatory. All right, well, thank you. Have a good day.